All right, so we are now going to turn to some higher cognition, what is typically considered to be higher cognitive functions. And we're going to start off with problem solving and creativity. So, what we're going to do today is we're going to start as we usually do, very, very basically. So, we're starting with problem solving. So, what is a problem? We'll come up with a definition of what a problem actually is. And then we're going to take a look at some of the challenges that arise when you're trying to do problem solving. So, oftentimes, when we try to solve a problem, we find ourselves stuck. We find ourselves unable to move forward. We find ourselves unable to get to that solution. And we're going to see that oftentimes the cases or the phenomenon that is causing that are things like restructuring or the failure to restructure, things like functional fixedness, working way too well, things like a mental set taking over your thought patterns, incubation effects not being allowed to occur, and then maybe it's just the nature of the problem itself, because sometimes these problems are known as insight problems. And as we're going to see, insight problems are the kind of problems where you might be making progress, but you have no idea whether you are. All right, so let's start off with what is a problem. So, for something to be considered a problem to a cognitive psychologist, so this is a very narrow definition of what a cognitive psychologist says. This is what we talk about when we talk about a problem. Well, it requires two things. It requires an obstacle between your present state and a goal. So you're somewhere, but you want to be somewhere else, right? You are in a current state and you want to be in a different state. So you have an obstacle, and there's an obstacle between the two. You have an obstacle between your present state and a goal, and it is not immediately obvious how to get around the obstacle. So this is the two aspects that we need for a problem to exist. So you have an obstacle between where you are and where you want to be, and it's not immediately obvious how you're going to get around that particular obstacle. So one of the beginnings of problem solving as cognitive psychologists came with Kohler's work on chimpanzees and chimpanzees problem solving. So we're going to take a look at some video from 1927. So this is clearly very, very grainy, but we're going to see some of the work that Kohler was doing on chimpanzee problem solving. And just notice how in each case, there's a present state that the chimpanzee is in. There's a goal that the chimpanzee wants, typically a banana, and it's not immediately obvious how to get around the obstacle that is separating those two. All right, so in this case, we have a chimpanzee in a present state on the ground. They want a goal, which is the banana that is hung from the ceiling. There's an obstacle between the two. That is that they are not tall enough to just jump up and reach the banana. So now they are going through problem solving and trying to figure out how they can change that obstacle or how they can get around that obstacle, in this case, by building up a structure that they will be able to climb up on in order to reach the banana. Kind of want him. I kind of want to wait until he makes it. I'm like, come on, man, get that banana. You can do it. I know. I know. He is. Except eventually, I think he does. Yeah, there we go. All right, we'll leave him there. Okay, so Wolfgang Kohler did a bunch of studies on chimpanzee problem solving. So we had obstacles such as there's a wall between you and the banana. So chimpanzee in the present state, no banana. Goal wants the banana. Wall is the obstacle in between. Not immediately apparent how they're going to reach that banana, but eventually they solve the problem. They put two sticks together, they put it through the gap in the wall, and they're able to drag the banana closer to them. We saw the example of the banana being hung from a height that the chimpanzees can't reach. So obstacle, banana is too high. That's the goal. don't know how to get around that obstacle. Through problem solving, come up with the idea of stacking boxes and crates so that they can reach it. And then different problems can be solved in different ways by getting around the obstacle in different ways. So some chimpanzees stacked the boxes until they themselves could reach the banana. Other chimpanzees used a stick and swatted at the banana until it fell to the ground, removing the obstacle between their present state, I'm on the ground, and their goal, banana. Now banana's on the ground, no longer a problem, immediately obvious how you can get around the obstacle of getting that banana. So that's the idea of problem solving. So what we're going to do right now is we're going to attempt some problem solving on our own. So what we're going to do is we are going to do some wordies. So not wordles, but these are wordies. And what they are is they are picture word puzzles that illustrate a common phrase or word. So I'll give you an example, and then we'll see if how many of these we can solve. So this is the example. So we got Daffy, Donald, and Mallard. So we have 3 ducks. So we got Daffy Duck, Donald Duck, and a mallard is a duck. We got 3 ducks. They are all in a row. So this is the phrase ducks in a row, as in get your ducks in a row. So what we're going to do is I'm going to show you a few of these wordies and try to solve them. Don't yell them out, but just write down the solution if you have the solution, and let's see how many we can solve. All right, so try to solve the following wordies. Again, they're a common phrase or sentence that is represented in these wordies. All right, so let's try wordie number 2. All right, wordie number 3. All right, and I believe this is the last one. All right, so we saw 4 wordies. Anybody confident that they got all 4? Anybody confident that they at least got one? All right, cool. So we have some successful problem solving. I will give you the answers, but not quite yet. We have some successful problem solving. We have some unsuccessful problem solving, right? So we have your current state. You're looking at this wordie. We have your goal, figure out the word or phrase that the wordie represents. And some of you were unable to remove the obstacle between your present state and your goal. So what is it that is making some of these problems so difficult to solve? What are these obstacles between the present state and a goal that actually make it not immediately obvious how to get around the obstacle? What are these challenges to problem solving? Basically, what are some of the reasons that solving problems fail? So we're going to take a look at a few of those. Probably won't get to all of them by the end of today, but we'll take a look at a few. And the first one is one that we've encountered before, and it's the idea of restructuring. So one of the basic ideas of how we solve a problem, how do we remove that obstacle, is that in order to solve it, you need to represent a problem. So we talked about representation over and over again in this course. In order to solve a problem, in order to think about a problem, you need to represent it somehow. That's just a basic tenet of how cognition works. But sometimes you make those representations in the incorrect way. And that makes a problem difficult to solve. So some representations, some way of representing a problem makes that problem easier. Some representations of a problem make that problem possible. And by the converse, some representations of a problem make solving that problem difficult. And sometimes representing a problem in a certain way makes that problem impossible. So if you have a representation that has made a problem impossible, one way to solve it is to restructure that representation into one that makes it possible. Yep. It's exactly like the bird flying in the two train thing. So we'll get to that example in just a little bit. That was a nice callback in that case. But yeah, it's exactly that same way. You think about it in a certain way, and that obstacle gets massive, and you just have no way around it. You restructure how you think about a problem, and then all of a sudden the obstacle becomes much, much smaller, and you can actually apply the correct cognitive moves to get around that particular obstacle. So I do have a new example of this. So this is a math problem. So what is the number of the parking space containing the car? So I'll give you a few seconds to figure that out. Okay, so show of hands, how many people figured out the correct number? Okay, we got a few. Some of us unable to figure out the correct number. If you're unable to figure out the correct number, it's probably because you have structured this problem, you've represented this problem in a certain way. And if you can change your representation and restructure the problem, then the solution might become obvious. So let's try to restructure this problem. Okay, how many people can now solve what the number is? All right, so we got everybody. So the number is 87. You are looking at it upside down, but until you, and if you were looking at it and trying to solve it from here, then it made it impossible because you were like, well, 16, and then there's a 6, so it's 10 less, but then the next one goes up to 68, so it's 62 more, but then it's 20 more. Some sort of weird mathematical mega formula that I need to fit to these numbers. Cognitively impossible for a human being to do, a typical human being to do without, some sort of super computational network. However, that makes it actually impossible because you won't get to the right answer, which is 87. Restructure the representation, and all of a sudden that obstacle between your present state, what is the number, and your goal, I want to figure out the number, absolutely disappears. And as was brought up, this is exactly what we saw back at the beginning of the course when we took a look at the train problem in terms of how many miles has the bird flown by the time the two trains collided. And as you recall, if you represented that problem as a distance problem, that made it near impossible. That was the wrong representation. And if you found yourself in that representation, then you would be unable to solve this problem. However, if during that time you were unable to solve that problem, you restructured your representation. You went back to the representation of the problem and said, you know what, I need to change this representation. Let me think of it as a time problem. Then all of a sudden you realize that these two trains are going to collide in exactly 1 hour. The bird flies at 80 miles an hour, hence the bird is going to fly 80 miles, and the time required is seconds in order to solve this. So that's the idea of restructuring. Again, some representations make problem solving easier. So we're going to take a look at another example, and this is the monk on a hill riddle. So I will read this out and then give you some time to try to solve it. So at 9 a.m., a monk starts to climb a hill and spends the next 12 hours hiking to the top. He reaches the top at 9 p.m. and spends the night there in meditation. The next morning at 9 a.m., he starts to descend along the same path he used to climb the hill the day before. Taking his time, he reaches the bottom at 9 p.m. in the evening of the second day. And the question is, can the monk descend the hill so that he is not in the same spot at the same time on each day. I'll give you a few tens of seconds to think about that. We can get to a solution. Okay, so show of hands. Can the monk descend the hill so that he is not in the same spot at the same time on each day? How many people think yes, he could? All right, how many people think no, he could not? All right, we got a little bit of a split going on there. So let's take a look at how restructuring can help make this a little bit more clear. So some representations of this make the problem easier. And most people, when they think about this problem, the reason it's challenging is they think about it as two separate trips. And they'll think to themselves, well, what if he runs up most of the hill on the first day, right? So at 9 a.m., he just takes off in a sprint and then makes it up maybe like 80% of the way and then just takes super long time for the remainder of the hill. And then on the second day, what if he runs down the hill most of the way on the second day and then takes a lot of time for the remainder of the hill? What if he runs up half of the hill the first day, but then takes a long time for the second half, but on the second day, he runs down most of the hill and then takes a lot of time, for the rest of the hill? So typically what people will do is they will say, well, let me think about it. What's he doing on the way up? And then they'll say, and then what is he doing on the way down? Can he do something differently on the way up than he does on the way down in order that he will never be in the same spot at the same time on these 2 days? And if you represent it in that way, it is very, very difficult to come to the solution of this problem. So if you think to yourself, all right, we got a monk and he is going up that hill and he does something on his way up the hill, and then he spends the night and he turns around the next day and he does something on the way down the hill, it's very, very difficult to come to a decision of, yes, he will be able to traverse this trip so that he's not on the same spot at the same time on the consecutive days, or he will not be able to do that. Hard to make that decision. So representing it as two separate trips makes applying those correct operators very, very difficult. Representing it as two overlapping trips makes applying the correct operators easy. What that means is that you can apply the correct cognitive moves to solve this problem extremely easy. Because if you say, all right, let me think of it this way. There's the monk at the beginning of the first day. There's the monk at the beginning of the second day. Will those two monks be able to pass each other and not be at the same spot at the same time? And you can see that once you put it as two overlapping trips, there is no way that they can traverse this hill so that they're not going to at some point pass each other. When they pass each other, they are at the same spot at the same time on those consecutive days. So the answer to the problem is, it is impossible for this monk to go back down the hill so that he is not at the same spot at the same time on that second day. So some representations make solving the problem possible. I'll give you two examples here and then we'll wrap up for the day. The first one, they both actually come from psychology. The first one comes from cognitive psychology and conscience experience. And basically, why we have conscience experiences cannot be answered with classical cognitive psychology concepts. So you will notice that throughout this entire semester, we have never at some point at all ever said, this is cognition that requires you to have a conscious experience. That was never a requirement for anything that we did. And that is because those concepts that we use, the theories that we use, they don't require consciousness. So the question is why do we have consciousness? How can we have consciousness? And as it turns out, we have structured our knowledge of psychology in a way that makes that extremely difficult to solve. So the physical symbol system theory, very difficult to figure out where consciousness comes from. Classic cognitive psychology representations of mental processes, even the connectionist idea. If you could go into the connectionist architecture and search where is consciousness, even if you could traverse the entire thing, you will never get to that place where you can find, oh, there's consciousness. So that's a sort of overarching psychology idea. What we're going to leave you with, though, is this real quick story from Rory Sutherland. And he is a marketer that is pushing towards trying to get the world to reconstruct and restructure what people think are engineering problems into psychology problems and try to solve the problems with those. So he's talking about the Eurostar train system and how they attempted to improve the Eurostar train system so people would be happier with their commute.
And what that means is that in looking at solutions, we've probably given too much priority to what I'd call technical engineering solutions, Newtonian solutions, and not nearly enough to the psychological ones. You know my example of the Eurostar. £6 million spent to reduce the journey time between Paris and London by about 40 minutes. For 0.01% of this money, you could have put Wi-Fi on the trains, which wouldn't have reduced the duration of the journey, but would have improved its enjoyment and its usefulness far more. For maybe 10% of the money, you could have paid all of the world's top male and female supermodels to walk up and down the train, handing out free Chateau Petrus to all the passengers. You'd still have £5 billion in change, and people would ask for the trains to be slowed down. Why were we not given the chance to solve that problem psychologically? I think it's because there's an imbalance, an asymmetry in the way we treat creative, emotionally driven psychological ideas versus the way we treat rational, numerical, spreadsheet-driven ideas.
Okay, so he makes a very, very interesting point that it's actually very, very promising for everybody in this room because all of you are getting very intimate and very knowledgeable about psychology solutions. And what he was basically saying is that they had this problem with the train. People were unhappy about the trip on the train. And they gave it to engineers, and engineers constructed that problem in a certain way. Oh, we need to make the train faster. So we're going to spend all this money. We're going to make the train faster. They reduced the time by about 40 minutes. And that was their solution to the problem. If they restructured their solution and said, well, maybe we don't have to make the train faster. What else can we make to make this train better? What else can we do? Maybe a psychology problem. If they could have restructured that problem and said, well, hey, what about making the experience better? Put some Wi-Fi on the train, makes the seats more enjoyable. He suggested hiring supermodels to hand out alcohol, all you can drink on the train. Would have been a less costly solution and would have increased or solved the problem way, way better. So again, they came to the problem representing it in a certain way that said, we need to solve this with an engineering solution. And if they had just restructured their ideas and said, no, this is a psychology problem or could better be solved as a psychology problem, they would have done much better. So that might be in your future, wherever your employment might take you, you might be in a situation where people keep pushing for engineering problems, for engineering solutions, for accounting solutions. And you might be the voice in there saying, well, what about this reconstructed way of solving this problem? Let's take a look at a psychology solution. And that might be the way to get it done. Any final questions or comments on this before we wrap it up for today? All right, so that is it for today. We will get back to the wordies. I'm going to have to leave you hanging until Thursday, but do not worry. We will give you those solutions next time. And hopefully, if what I'm hoping happens actually does happen, we'll see a nice little problem-solving effect. But all of that is going to be next time. Other than that, we are done for today.